So continuing to look at how we can calculate lengths of sides in non-right angled triangles, and today we're going to make something called the cosine rule to do this. So your learning intention today is to learn how to calculate a missing length in a non-right angled triangle, and your success criteria based on that will be if you can use the cosine rule to do that. This, remember, is all in trigonometry. You'll be using your thinking skills, communication skills, organisational skills. There are lots and lots of careers out there where trigonometry is used. Mainly probably the initial ones that you might think about are engineers, building inspectors, surveyors, people like that. There's a whole list of people there who will use this type of trigonometry. So you've been introduced to the sine rule. The sine rule is a statement that compares the opposite side to the sine of an angle, and it says in every single triangle your opposite side compared to the sine of the angle that goes with it will be equal to, all three will be equal to each other when you take them in pairs like that. So we can use that sine rule. You will usually always be looking to just use two pairs of those ratios at a time, and it can be used to get the length of a side, or in fact you can also use it to get the size of an angle. Just a little small note, just in case you're not aware of this, but the smallest side is always opposite the smallest angle, and your longest side is opposite the largest angle. You're aware of that in a right angled triangle where we talk about the hypotenuse, because the largest angle in the right angled triangle is the 90-degree angle. The side across from that is the hypotenuse, which is the longest side. So here, if I asked you to calculate the length of side x in this diagram here, so I would have the diagram drawn. I would have my sides named. So remember, lowercase letter opposite angle x, angle A is lowercase letter a. This one here would be side B, and this one would be C. So if we then ticked off what we know, and we can see in this that we are trying to work out the size of A. We know angle A, so we can put a little tick there that we can work out the sine of A. We know side B, so we can put a tick. We don't know angle B. We know side C, so we can put a tick there. But if you're looking at that, we do not have two ticks on any one of the fractions. So in this particular situation, we are unable to find the length of x using the sine rule. So what happens is we then use this other rule, which is known as the cosine rule. It looks a bit more complicated, and basically in order to be able to use this cosine rule, and this appears on your formula sheet, this says a squared, so this side here squared will be equal to your other two sides squared added together minus, now this 2bc cos A, that's all multiplied together. Now notice that your formula, the side you're trying to work out is lowercase letter a, and the angle is what is with the cos at the end of this, and all the other letters in there are from the two sides that you know. So basically, in a situation where you've got, notice here, the two sides that we've got are the B and the C, and the angle that we've got is in between those two sides. So when that happens, that is when you're going to be using the cosine rule. And if we look at that previous example, that's what we had. We had two sides and we had the angle in between those two sides. So whenever that happens, it is going to be the cosine rule. Now obviously it's not always angle A that you've been given, you might have other letters going on in there. So for example, if you were given angle B, then the two sides that you would be working with would be side A and side C. And in order to use that, so kind of highlighted, if it was side C that you were trying to work out, then, and you were given angle C, then it would be sides A and B that you would work with. So this is in your notes, page 40. There's the cosine rule written out. So find in this first example, find the length of the missing side. So we can clearly see we've got two sides, we've got the angle in between them. We don't have letters on this particular diagram, but we can introduce letters, and given that the formula contains the one where you've got the angle A, then you can put in your B and your C. And then from that you're able to label your lowercase letter b, lowercase c. So subbing into the formula, you get a squared will be equal to, so this is the length that we're trying to work out, the BC, finding the missing length. So a squared will be equal to 11 squared plus your 7 squared minus 2 times 11 times 7 times, so you need to be putting multiplying signs in between all this, cos 58. Now you can do all of that on the calculator. It's obviously not going to come out exactly because that cos 58 will have a decimal value, but when you do this it comes up with 88.3924. You should write down that number but leave it in your display. And what you're going to do to your next line, because this is what a squared is equal to, but we need to take the square root. Now, so that we're not trimming twice or rounding twice, you can press on your calculator the square root symbol. If you've left that 88.3924 and all the other decimals in the calculator, press the square root symbol followed by the ANS button. And what that does is it takes the square root of what's in your display and it saves you typing all of that in again. And if you do that, you're going to get your answer of 9.4017 whole load of digits. So we would then get 9 point, if we were rounding that to two decimal places, it'd be 9.40, and that would be centimetres. So just to go over that again, there's the formula which you would get for the formula sheet. You should have your triangle drawn, label your sides, get your numbers all in the right place. This needs to be written out, that 11 squared plus a squared equals 11 squared, etc. And you're going to be taking the square root of all of that number, but you need to write that down first. This here, when you get that in your answer, you will be pressing the square root symbol followed by the ANS button is next to the equals button, and it means you don't need to write all that out again. So second example, beside that, this time we do have letters on the triangle, but it's in terms of P, Q and R. So if we filled in on that diagram, this side opposite capital P would be lowercase letter p, this would be Q, and the missing side, the one we're trying to work out, is R. So when we look at this formula here, we would be writing down R squared equals, we use the other two sides, P squared plus Q squared minus 2PQ cos, and then notice it is capital R at the end of that. So filling everything into this, that means that you're going to have your R squared will be equal to your P value is your 14 squared plus your 11 squared minus 2 times 14 times 11 times by the cos of 64 degrees. You do all that in your calculator, you will get a value 181.9816, whole load of other digits, and remember all you need to be able to do is the square root of that number. So remember that means that you would be doing, leave this number here that you got in your display, press the square root symbol followed by the ANS button. You don't need to write that bit out, I'm just writing that out for you, and that will bring up your value of 13.4900, whole of the other digits, and you get 13 0.49 centimetres. And that's it. So now you're going to go and practice using that. Please make sure you draw the diagram. Make sure you're thinking about your letters and so on. It is a good idea to have the formula written down and keep writing that down when you do this. So exercise 8.5, and you're going to do questions 1 to 5.